The scale or resolution of textures used in a scene also play a big part in the texturing workflow, given that they can make or break the realism of an Unreal level. And so, let's talk first of all about the subjective scale. Unreal by default uses a unit measurement of centimeters, meaning 1 unit in an Unreal scene is equal to 1 centimeter in real-world terms. And although there may be times in both game and on ArchViz projects where we won't want to work at a real-world scale, such as when creating extremely large open environments for instance, there are certainly benefits to doing so should we be working on smaller, more compact levels. Building up an environment, for example, becomes much easier when done using real-world units, as we can now measure real-world spaces and objects, and then both recreate and light them in a manner that closely resembles the way in which we would see them in real life. When it comes to materials in Unreal though, it is good to remember that there are actually two types of scale that we need to keep in mind. So, we have the scale of detail that may have been captured inside a material and our texture map, and we have the actual scale of the static mesh object as it appears in the level. To demonstrate why understanding that difference is important, here we have two walls that are each made up of several components. Now, despite the fact that both are the same height, width, and length, one material seems to look more natural than the other. This is because the scale of the textures are different. The first has a texture that is 18 UK bricks tall, bricks that in the real world are roughly about 6.5 centimeters in height. For the texture to look right then, it needs to be applied to a surface that is about 117 centimeters tall, or about 120 centimeters if you allow for mortar in between each brick of course. The second wall, however, has a texture that is only 8 UK bricks tall, and because, as just demonstrated, the scale is off, the texture looks a little strange, as the bricks are taking up more space than they would in the real world, naturally making our material look odd. Now, if this were a procedural texture, we could just alter the number of bricks found in the map until we get what we want. As this is a bitmap though, we will instead need to increase the tiling found inside our texture coord node in order to bring things into line. Values of 2.25 and 2.25 here should give us a roughly correct scale for our texture. Although we can also see a lot more repetition in the texture now, and so it is best to get the scale right when working in the initial texture planning phase. Let's just set our tile values back to 1 and 1. It is also good to note that by default, the FOV of the character camera in a first-person template is set at 90 degrees, which can, in and of itself, alter our perception of things like scale in a scene. If we come to the first-person blueprint folder then, we can jump into the blueprints folder and double-click the character blueprint. If we select our camera in the Components section of the UI, and look under the Camera Settings rollout of the Details tab, we can indeed see that it is set to 90 degrees. If we set this to 35, and then compile and test the level though, we can see that the scale, or our perception of scale in the scene, now looks very different, highlighting that we may on occasion need to alter the perception of scale on our texture or static meshes if using an FOV setting on the rendering camera that is different. Let's make sure we go back and set the FOV to 90. Next up, we need to discuss the resolution of our textures. And so if we take a look at the second of our wall sets, we can see that we do also have a very noticeable discrepancy in visual quality. Something that is occurring because the larger the surface area of a static mesh, the higher resolution the texture needs to be in order to look good. So, whilst our 512 by 512 map works fine on the smaller wall geometry that we see here, it doesn't quite stand up to scrutiny on the larger wall. We could fake an increase in the resolution here by increasing the tiling of the map if we wanted, but of course that would also change the scale of the texture, which may not be something that we want if it is already set at the scale we need. When confronted with this kind of problem, the only real solution is to make use of a map that is of a higher resolution. And so, if we apply our 18 brick 1024 by 1024 texture to the wall instead, we can instantly see the jump in quality, hopefully highlighting the importance of both scale and resolution when it comes to texturing our visualization pieces. Remember, the bigger the mesh that we need to spread our texture across, the higher the resolution needs to be if we want our visualizations to always look the best that they can.